Thomas Phoenix, PE, FHRA, Chair, Advanced Energy Design Guide, Steering Committee. The subject of it today is Achieving Zero Energy. Since 2002, ASHRAE, the Illuminating Engineering Society, USGBC, and IAIA, with support from the Department of Energy, have collaborated on a series of advanced energy design guides that will result in significant energy savings in the built environment beyond what's expected by using ASHRAE standard 90.1. The AEDG series of documents is now one of the most popular publications in ASHRAE's history, with over 6,000 copies in circulation. This program will review a brief history of the AEDG series and then focus on the newest group in the AEDG series, Achieving Zero Energy. The first module in this new series is for Zero Energy K-12 school building design, and the program will highlight the major steps and integrated systematic approach for achieving zero energy schools. Please, Mr. Tom Phoenix, welcome to the stage. Big applause, please. I thought this is not enough. Come on, one more time. You have half an hour, okay? This is your... Yes. Okay, we have half an hour to join.
Okay, thank you. If you're a speaker, this is the worst time to speak. You're the first speaker right after lunch, which means everybody is ready to take a nap. So my job is to keep you awake.
This is why I put the picture thing in.
Yeah.
They woke up, don't worry.
Yeah, so now everybody had to stand up. That's good. So, how many of you have ever heard of the Advanced Energy Design Guides? Only one or two? Oh my goodness. Okay. Of the one or two that had their hands up, how many of you are actually using the Advanced Energy Design Guides? No? Oh, one. Okay, good. All right, so by the end of the day, and the end of this talk, everybody's going to go get one. If the theme of the CRC here is building our energy future, and the Advanced Energy Design Guides is a tool that you can use to help you do that. So let's get started. This is all the DL stuff. You should have an evaluation form. And a couple of the previous presenters already talked to you about volunteering for ASHRAE. So if you're not already volunteering in your chapters, please do so. Sign up for a technical committee. And this is what we're going to do here in the next few minutes. We're going to learn a little bit about what the Advanced Energy Design Guides are and where they came from. And then we're going to learn a little bit about the brand new one that just came out a few months ago and where we go next. So let's start with a little history. How many of you have ever heard of ASHRAE 90.1? I hope a lot of hands go up there. Otherwise, we're in big trouble. ASHRAE 90.1 is the ASHRAE's flagship standard. It's the energy standard. It's energy usage in commercial buildings. Okay. And 90.1 has been around for a while, going back to the 1970s. And around the turn of the century, the 1999 version of 90.1 was in effect. That was the latest version. And it was the first version of 90.1 to be identified as an energy standard in the United States National Energy Policy Act that was passed. It was also the first version of 90.1 that was being used in most of the states in the United States, as well as in some other countries, as the standard for energy design. and it became code, building code in a number of those areas. And around the turn of the century, again, the 99 version had been in effect for a couple of years, and there was the beginning of a discussion about where do we go from here? How do we get better than 90.1? And in 2002, a group was formed, the Advanced Energy Design Guide Steering Committee. Now, first thing to remember from this talk this afternoon, the Advanced Energy Design Guide Steering Committee is not an ASHRAE committee. It is not a part of ASHRAE's formal structure. It was designed and intended to be somewhat independent so that we could get expert opinion from other disciplines and from other parts of the building industry. So the Advanced Energy Design Guide Steering Committee was set up as a separate legal entity, and then we created memorandums of understanding for all the work we do. Now, ASHRAE is represented on the committee, but there are 3 other partners on the committee: the American Institute of Architects, the U.S. Green Building Council, and the Illuminating Engineering Society, the lighting engineers. They are all represented on the steering committee, and the steering committee so far, since it started, has been funded by the U.S. Department of Energy. So we created this steering committee to begin to think about how do we get better than ASHRAE 90.1. I'll go over the other bullet points on this slide here in a few minutes. This is the current steering committee. You may know some of these people, you may not. There are 5 voting members of the committee. I am the current chair, and then the list of names from the other partners. Of the 5 voting members, I only vote in case there's a tie. So far, there's never been a tie in a vote. The other contributors are people who participate in the steering committee as liaisons to other organizations, and then again, the U.S. Department of Energy has been our funding source since we started. So we decided to develop these advanced energy design guides. And the steering committee is not the experts that put these together. We only manage the process. And each one of the design guides is produced by a committee of experts. And those folks are selected. We'll talk about that here in a minute. It is intended to be, as you can see on the slide here, educational guidance. It's not a code, it's not a standard. It's guidance and procedures that you can use to make your buildings as efficient as possible. This is what we provide. These are sort of our goals. Using the Advanced Energy Design Guides, you can provide a way, but not the only way, to achieve desired energy savings. Now again, there's a way that you can follow in these books, but as you know from your experience as engineers and contractors and suppliers, there's always several ways to get things done. We don't attempt to try to show you every way, but we do show you a way. And that way is normally prescriptive, which means you can go to a table and figure out how to get to where you're going. However, there's a lot of information you might need that's not in a table. And so the guides promote the use of energy modeling, and I'm talking about advanced energy modeling to make sure that the procedures that are followed are intended to give you the correct results. Each guide has a set of how-to tips, and then there's a set of things that you don't want to do, because there are lots of mistakes. So we started in 2002, and we developed and set a goal to do these publications to get you 30% better than ASHRAE standard 1999. So if you follow the procedures in each of these advanced energy design guides, you would achieve a 30% savings. And we produced 6 of these. There's a separate one for each building type. You can see small office and retail stores and schools and hospitals, 6 of them. And they have been quite successful. Currently, the 30% guide over the last, it's been 10 years now, but there have been over 400,000 copies distributed of the 30% guide. So here's one thing I want you to never forget. You see this down here? Those guides are available to you at no cost. They're free. So I'm not up here selling you anything other than I want you to start using the Advanced Energy Design Guides. They are free. You can go to ASHRAE's website and download them for free. I mentioned to you that this was not an ASHRAE committee. What I should tell you is that because of the contractual relationships we have, ASHRAE is the publisher of these documents, and ASHRAE is the secretariat for these documents. The staff support has been provided by ASHRAE, but they're free. So from 2002 until about 2009, 2010, we published these 6 books, the 30% guides. But then in 2010, a couple things happened. First of all, the 1999 version of 90.1 is way out of date. We had a 2004 version, we had a 2007 version, and the 2010 version was coming up. Plus, we wanted to be better than 30%. So the committee changed focus, and in 2010, we started thinking about 50% better. Not only 50% better, but 50% better than the 2004 version of 90.1, which was even better than 1999. So now we're really talking about energy savings. And the first of these 50% guides was published in 2011. And again, look down at the bottom, you'll see this on a lot of slides. They're free. They are no cost. Okay? And so we published these guides starting again in 2011. In the fall of 2015, well, let me back up, because this is always a question. Well, how do these guides get produced? I'm getting ahead of myself a little bit here. So the first thing that happens is, in these 11 guides that are now published, this is how the process works. The steering committee selects the topic. Now, how do we select the topic? There has to be a market for it. Somebody has to say, I wish I had an advanced energy design guide for schools. So there has to be a market there. There has to, and sometimes there's already research started. And so we have a way to get some good information because people have already started research. Okay? Once we decide what the topic is, we select the project committee. Now, this committee is not necessarily ASHRAE members. They're not necessarily members of any of the other partners I told you about. they are industry experts, and they can come from anywhere. In fact, every committee so far has had representatives on the committee from outside North America. So, and ASHRAE, as you know, is a global society. So we are looking for folks who are expert in that building type to sit on the committee. They begin to develop the methodology to get to 30% or 50% or whatever using ASHRAE 90.1 procedures. And if some of those of you familiar with 90.1 know about Appendix G in the back, there's a whole procedure for making sure that your building is better than a baseline. And that's what we use. Now, the other thing that happens is we want to be sure that the procedures that we give you in these guides will really work. And so we contract with the National Renewable Energy Lab or the Pacific Northwest National Lab. They're two of the national labs in the United States to run simulations. And they run very advanced computer models of all the procedures that are in these guides. And they do it for every climate zone. There's all the defined climate zones, not only in North America, but around the world. The national labs do this for us under contract. They produce very advanced energy models and simulations. And then they provide to us technical support documents that say, yes, this is going to work and here's why, and et cetera, et cetera. By the way, when you go to ASHRAE's website to download one of these advanced energy design guides, all of those technical support documents are there for you to read as well if you are interested. So then the project committee writes the guide and they start producing, drafts, first draft, second draft, and at 60% and at 90%, we put that draft out for public review. And so you can download them and review them and make comments. And we get lots of comments, and that's a good thing. That's how we know we're doing it right or we're doing it wrong. We get comments. And then after the 90% review comments, the steering committee develops the final implementation plan. And when are we going to release it, and what kind of marketing are we going to do, and all of that. So that's how each one of them is represented, right? And each one of them, by the way, I stuck this in here because everybody asked a question, is there a how-to guide? The answer is yes. I pulled one out of the 50% guide for hospitals, but there's a chart or a guide like this in every one of them that says, this is how you do this, okay? And by the way, these books are not just for engineers. They could be used by building owners, they could be used by developers, by contractors. Again, these are procedures that you can follow. Okay, so here we are in 2015. We've got 11 guides published, 30%, 50%, 1999, 2004. And our circulation is now up over 600,000 copies. So it is a very, very popular guide. And in the fall of 2015, I was asked to chair the committee. The person that was the current chair was moving on to other duties in ASHRAE, and they asked me to be the chair of the committee. So I said, okay, fine. And the first meeting that I attended, the first face-to-face meeting, was in early 2016. And the committee started talking about the next series. And the next series was planned to be 70%. 70%. Let's get the 70% guide. So during that meeting, I kind of posed a question to the committee. I said, guys, 70% of what? I mean, the 50% guides, the baseline is 2004, 2004 ASHRAE. But now we have a 07, and we have a 2010, and we had released a 2013 version of 90.1. So, are you going to get 70% better than 2013? I don't know, you could, I guess. But is that what we really wanted to do? Where is all of this headed? And so after some debate, the committee decided to scrap the 70% guys and shoot for the moon. And we decided that we wanted these guys to get us to zero. Zero energy in a building. Achieving zero energy. And we talked about it, we decided to do it, we launched the project, and we decided that our next series was going to be Achieving Zero Energy. What we didn't want to do was change our integrity. We wanted it to be recognized as very scientific, the procedures to be recognized as correct, and so we followed our same format. We decided, you know, we're not going to change the way we do things, but we're going to shoot for a different target. And we decided that the first version of the new series would be directed to schools, kindergarten through grade 12 schools, because there was already some research going on at the Department of Energy and some other places about K through 12 schools. So, here's a couple things. When you decide you're going to do this, the first thing you have to decide is, what is your definition of zero energy? And believe me, that is not an easy question to answer. There is a lot of different discussion. There are a lot of different definitions out there right now. What we chose, because the Department of Energy funds most of our work, we decided to use the U.S. Department of Energy's definition for zero energy. And there it is in quotes up there. You can read it. I highlighted two parts of that. First is the part that says source energy. Does anybody know the difference between source energy and site energy? Yeah. Okay? Oh, good. There's a number of hands. All right. We'll talk about that in just a second. The other part that I highlighted was this on a source energy basis, the actual delivered energy is less than or equal to the on-site renewable energy. Now, I made a presentation about this time last year in Italy about this. The new guide was just underway, and we were really excited about it, and I got invited to a conference over in Naples, in Napoli, Italy, and I got clobbered about this. And I just want to tell you, there's some controversy, and I'm not trying to dodge the discussion, but the people in the audience at that conference in Italy kept raising their hand, and they kept saying, there is no such thing as a zero energy building. And they have a good argument. I'm not going to, what they said was, you can achieve net zero, but never zero. And I don't disagree with that. I think it's a question of labels and a question of semantics. This is the definition that we chose just because that's the U.S. Department of Energy's definition. Okay? And what does that mean? What that means is, and this is a diagram right out of one of the guides, you will see energy that comes in from the utilities, It may also be energy that's delivered to the building from renewable sources on site. And then you have energy that you have to use to do heating and cooling and ventilating and all those things you see up there. If the renewable energy is greater than the amount of energy that's being pulled into the building from the utilities, then you have exported energy, okay? So a zero energy building means that the renewable energy is making up at least as much as this or more. That's the definition, okay? So here's how you do that. And if you don't learn anything else this afternoon about trying to get to zero energy, this is what I want you to learn. This is the slide I want you to never forget. The first step is to make your building as efficient as possible. Do not try to just match whatever you're doing in your building by putting that many solar panels on your roof. That's not how you do net zero, at least not the way you're supposed to do it. The first step is to make your building as efficient as possible through all the things you see up here. Changes in behavior, I should underline that. Okay? Make your building as efficient as possible. I could make this building right here a zero energy building in about 5 minutes. I can go outside and pull the disconnect on the building and everything goes dark and you're using zero energy. But is the building usable? No. No. I mean, that's not practical. But what you do want to do is when you power the building up, you want it to be as efficient as possible. Then, and only then, you make up the difference with renewable energy. Okay? You don't learn anything else. This is what we're trying to achieve. Okay, so we had this discussion. The project committee went to work. It's here. This is the new version of the Advanced Energy Design Guide. It's the zero energy for K through 12 schools. It was published in January of this year. It already is approaching 70,000 downloads just by itself. Okay, so it's automatically a big success. And so I got a lot of slides here about the guide and some of what's in it and all that stuff, and in the interest of time, I'll kind of go through that. But this is what we were trying to accomplish. We wanted to make sure that
we have like another 5 minutes to go.
Okay.
Oh yeah.
Well, now I'm really at this slide.
We've been learning. I mean, this
yeah.
is something.
So we wanted to make sure that zero energy schools we could do and give and provide you the direction and the procedures to make that happen in every climate zone, including all those climate zones outside North America. And then these are the goals. It has to be financially feasible, it has to be workable, and it has to be achievable and measurable. Okay? These are some of the principles. One of the reasons that we do different books for different building types is because they are different. And some of these slides that I'm just going to buzz through here in just a second talk about what you have to look for in a school. You have to get buy-in from the staff. You have to get a change in behavior, and you want to create a learning environment as well as a zero energy building. Okay. Owner project requirements. We could do a whole another talk about that. This is what I was talking about. You have to engage the people that are going to use the building. Okay? Otherwise it's going to fail. If they're not on board, your project's going to fail. We talked about source energy and site energy. Source energy takes into account the fact that it takes energy to make energy. The site energy is what goes through the meter at your building. Source energy is the amount of energy it takes to get the energy generated and transmitted to your building. Okay? And in the U.S., there's about a 3.4 multiplier. It takes 3.4 times as much energy to generate it and transmit it as it does for you to use it. And so that's why there's such a big debate about this. We talked about modeling. These are the things that you have to model. And this is just a chart that says, in this book right here, those are the number of tips and strategies in each sort of category. Like in HVAC, we have 37 tips in this book that you can do for HVAC. Okay? And I'm going to zip through this because I'm going to run out of time. These are examples of the things that are in the book and the various strategies that you can look at and talk about. So I'll stop on this one because this is something you need to understand. Because we decided to do a zero energy guide, everybody thinks, well, okay, that guy's going to tell me all about how to do solar heating and solar photovoltaics and all that stuff. It's not. There are lots of procedures in there for making your building efficient, but it is not a renewable energy guide. There's a lot of discussion about renewable energy, but it's not going to tell you how much or what type or any of those design considerations. There's a case study here. There is a number of zero energy schools already in the U.S. This is one that followed our procedures. This is in Arlington, Virginia. It's Discovery Elementary School. There are a number of slides here that again, it really is just showing you that it can be achieved and how to achieve it. The school principal in this case took this project on as her own. She got obsessed with it. And so we had a champion during the design and construction of this project. And we did achieve it. That they have high performance learning. They have integrated food service. That's a huge energy consumer in the school, is the cafeteria and the kitchen. And they continue to monitor the thing. This is a picture of even the students there are very involved, and they're helping put up the solar panels. And they actually have this is a big screen in their lobby, okay, that tells them what's going on all the time, how much energy is being consumed, how much energy is being generated by the panels. And you can, and if you go to that website down there, you can actually see the screen. You can, from anywhere in the world. Again, it's achievable. So what's next? Well, the K through 12 guide, as I said, has been very successful. And so it looked like we were on the right track. So the steering committee said, okay, let's keep going. And so we decided, we did some research, and we decided that the next guide that would be a good place in the market was for small to medium office buildings. And so we're off and running. And as you see there, the next zero energy AEDG is already in development. And it's going to be called Advanced Energy Design Guide for Small to Medium Office Buildings. The project committee was selected back in March or April. They actually are, and they began to meet. Excuse me. They actually are meeting right now. They're in Atlanta. Yesterday, the 4th, 5th, and 56. So that, I guess that was yesterday and today and tomorrow. The project committee is meeting in Atlanta. We had a public review that was sent to the public on the 31st of August. Those public reviews last about 2 weeks. And so that first review is over. The next review is scheduled for November the 2nd. Depending on what they do this week, that might move a little bit. I think they're a little behind, and they're going to talk about it when they were in Atlanta this week. But somewhere in the first part of November, you should be on the lookout for the second public review, which is basically the 90% review. And then after that is over, we have set a date that we on the steering committee want to see the final product. And that date is March next year. And the goal is to be on the street and published by the end of May next year. I'm done.
Thank you. This is a very interesting presentation. Do you? I will ask the first question, then you ask the second question. Okay? Can we do that?
Yeah.
This is an amazing thing. I mean, really, I hope we can get more zero energy buildings. I mean, if in America, I'm just asking if someone wants to invest on this, if I want to make my office a zero energy building or a school, I mean, does the government subsidize any of the expenses, or how does it work?
So the answer is it depends on where you are. But in the U.S. there are currently, although the life of them is somewhat in debate, there are currently some rebates, some small rebates for renewable energy equipment. And then each state in the United States is offering their own rebates, and the utility companies in the United States are offering rebates. Where I live in North Carolina in the U.S., the utility company is currently offering some rebates for renewable equipment, and there are tax credits at both the state and local level. But I will tell you, if you want to do that, you better hurry up, because there's a lot of discussion at both the state and local level for eliminating a lot of that. Outside the U.S., I have heard about several research programs, rebate programs outside the U.S. So it kind of depends on where you are. Now, let me add on to that. You saw the slides for Discovery Elementary School in Virginia, and I apologize for zipping through a lot of that stuff, because he was about to get the hook out. But when it was all said and done, the cost of going zero versus what they were originally planning to do at that school was only a little less than 5% greater by the time you got the rebates and all of them, and the tax credits and things like that. Their initial cost only increased about 5%. So all of this is very doable.
Thank you. Question, yes.
Yeah. Tom, very interesting presentation. I wish they had allocated more time to you. Now, the question is, no matter how efficient the building is,
Yes.
still you need some energy, right? Now, you talk about net zero. So in this case, what kind of energy was being put in to make it a net zero? I hope my question is clear.
Did everybody hear that? He was asking what kind of energy can be counted on as renewable energy to put into your building. Yeah. So 99% maybe of the projects that I've been involved in and know about and have seen in the production of these guides, it's all about putting electricity back in your building. Now, I understand that there are geothermal and there's solar heating and all of that stuff, but the renewables are typically back in your building, that can be done, and I've seen it done in a number of ways. The more popular and the one that gets all the press is photovoltaics. Here's the issue with photovoltaics as it's currently in the current technology. There's only so much electricity that you get out of a square meter of photovoltaic. And if you don't have much of a roof, or if you don't have a site to build a big solar, you're not going to get much, okay? And so, even though that's kind of that's the first thing people think of when you think about renewable energy, but there are other sources. There's wind, and then there's hydropower, and then even if you have access to it, there are geothermal sources that can, drive turbines and things like that. So there are other ways to do it, but is that an answer to your question?
Yeah, I wish I had seen that case study, the one you were going to.
Well, okay, so if you're referring to Discovery Elementary, that was 100% photovoltaic. They had enough, it's a big school, so they had enough roof area to put photo cells up on the roof, and it was 100% photovoltaic.
Oh, we have more questions, okay.
Thank you very much for the fine presentation. My question is, when you do energy economy, you know whether something is zero energy or not. Do you consider all energies as equal? For example, you take electricity from utilities or natural gas. Do you consider them as 1 unit each, or do you consider the exergy content? Because as you know, it takes like maybe 3 units of natural gas energy to produce 1 unit of electricity. So do you make this distinction based on exergy content?
So the short answer to your question is no. And did everybody understand that? Is there a distinction between the different types of energy as a part of this discussion? And the answer is no, because what we're looking at is energy. Whether it's generated with natural gas, whether it's generated with electricity. There's steam plants and there's many cities in the United States. New York is one of them that has a central chilled water plant. If you want to build a new building, you have to buy chilled water from the utility. Those are all pieces of energy that are entering your building. And so if you bring all of that to a standard unit, a common unit, in the U.S. using the IP, it's BTUs, and so there actually is a measurement that the U.S. government puts out. It's called CBEX, and it tells you how many thousand BTUs per square foot per year is used in a building. And if we flip through these slides, and part of those slides is showing you how here's a standard, and these buildings got down to really low numbers. So, but the short answer to your question is, you bring it all down to a common unit of measurement, and that's that chart that had the arrows going in and the arrows going out. All of that going in is counted and normalized to 1 unit of measurement, BTUs or joules or whatever. Okay, and then the amount going in from your renewables is counted against that, or to come up with either a net zero or you almost made it or something. Okay. Yes.
I'm consulting from Turkey.
Yes.
Nowadays we are speaking about energy capacity and zero energy. What is your perspective for the future energy source? Will it be facade or just photovoltaic?
That's a great question.
I think we couldn't hear the question. Can you repeat the question?
Yeah, the answer is what's in the future. Today we're talking about net zero energy, et cetera, et cetera. in the future?
I want to clear my question.
Abi sesin
Okay.
gelmiyor. Biraz mikrofonu tutar mısın ağzına?
Şöyle.
Kapalı şu anda.
Şimdi duyun. Tamam, okay.
Okay,
Okay, I'm consulting engineer from Turkey.
right?
Nowadays, our target is yes, zero energy building and also energy class building. And energy class buildings is coming from Germany. The target is energy class building. What is your perspective for energy producer in the building? Is photovoltaic or facade also will be featured?
So,
I have one more question. Is the thermal storage and the ice storage is the target of this kind of buildings? I mean, nearly 100% buildings will have this kind of system.
so if everybody understood that, there's two questions there.
Yeah.
One is somewhat the same question that he answered, which is, or asked, which is, you know, what kind of energy, the energy plus the German program, I don't know that I'm familiar with, but the answer to your question is, again, it depends on the location. It depends on where you are. It depends on what is available. If you don't have, again, to repeat what I said earlier, if you don't have a lot of roof area, photovoltaics is not going to be your first choice. You may have to look at wind or something else that you can use to generate electricity. It really depends. Now, your first time you asked the question, I heard, what's in the future? I don't know. I mean, the technology is advancing all the time. And I do remember when people first started talking about photovoltaics, you wouldn't even think about it because they weren't efficient. The panels that you would buy generated very little electricity per area. Now, they're about 5 or 6 or 8 or 10 times, depending on whose manufacturer you want to talk about. They're about 5 to 10 times more efficient than they used to be. And I keep hearing about technologies where you can generate a lot of electricity in a little tiny little thing. I mean, technology changes all the time. So today, a roof that doesn't have enough space to even think about photovoltaics, maybe in the future they could. I will tell you, I went to 2 meetings in Washington back a few years ago, and the meetings were all about planning for the day when every building, when there is no utility company, when every building generates its own power. And I thought it was very fascinating. There were lots of pros and cons and all of that, but I think, you know, I might not be around to see it, but I think in the not too distant future, we will be looking at that situation where the technology has changed to the point where every building can have enough renewable energy to generate their own power.
I have a question. I have a question here.
Building facade. What is your idea about building facade? There will be.
I can't, I'm sorry, I
He's
can't.
talking about building facade.
Building facade, you know,
The facade?
He's talking about the envelope.
Yeah, the building envelope, yes. There are changes occurring today in the technologies there as well. I made a talk like this a couple weeks ago to an association of door manufacturers. And I had to kind of tell them, you guys are way behind because the window manufacturers have been improving their product to where now, you know, when I started, everything was a single glazed window and had almost no thermal resistance, and now the windows, you know, the solar heat gain has been eliminated, and the U factors are very low. other parts of the building envelope, and the insulation is getting better. The air tightness, that was one of the slides that we zipped through. The air tightness and the air barriers are better. The door manufacturers are way behind because they, and that's not a criticism too much. It's not their fault. Doors open and close, and it's an infiltration.
And we have one last question.
I
Then we have to wrap it up.
Yes.
Just to follow up what you said. You are saying the envelopes are getting better, but we are putting curtain walls with all glass buildings and assuming it's going to be energy efficient.
Yes.
We need to stop architects using these curtain walls. Okay.
Well, so I'm a consulting engineer also, and my firm where I work, my paying job, not my ASHRAE job, we're an architecture and engineering firm. So my partners and my friends at work are all architects, and I have an engineering group. And we have discussions like this all the time. And some of the new energy codes, began to limit the amount of glazing and things you could have in a building. As long as the glazing products continue to improve, then we can use more and more and more. But you're right. If you wind up with a curtain wall that's all glass, then you're already a little bit in trouble. Yeah.
I used to live in the U.S. and in New York, and I worked
We have only 1 minute left.
Okay.
I worked on Staten Island Net Zero School project. That was by Bloomberg in 2010. He wanted to have a net zero in New York City for SCA. We designed that building. If you look at that building, there's no single spot on that roof that you cannot put a PV panel. It's full with PV panel.
Yeah.
But major challenge was you need to make it simple enough that custodial can operate that building.
Right.
Because we go so crazy, we want to make it net zero. I don't believe zero. I believe net zero. And actually, you need to define net zero as a source or site. And we were going with the site, not source, because there's a lot of unknowns there. And that design was supposed to be so simple that you could just operate with a custody. But the biggest problem comes after that. You design it perfect, but that you have to make sure that it is staying in that design condition because it changes. People don't know how to operate. My question to you, when you say net zero building, what's the benchmark that you need to consider to be able to achieve the net zero?
So that's a great question, and I get asked that a lot. The answer to the question, if you didn't hear it, what's the benchmark? And the reason people ask that is because up here on the slides I showed you, we've been using 90.1, either 1999 or 2004 or whatever, as the baseline. For a zero energy building, at least the way it's defined, the baseline is zero. I mean, we want to, if you've achieved net zero, you can't get any better. I don't care what the baseline is, you have achieved net zero. We have this debate, by the way, in our steering committee meetings. We keep talking about, okay, if technology changes, and it's going to change, when technology changes, what's going to be our new standard? And the answer is, well, maybe you don't have to have so much renewable energy if your building is a little bit more efficient, but if you are able to achieve a building that uses so little energy that you can make up the difference with renewables, that's kind of the holy grail. That's you have achieved net zero, and that's what you want to do. And there really isn't a baseline to compare to. You've gotten to zero, and that's what you want to do.
Yeah, well, we are just considering electricity. We have gas.
Excuse me, I have to stop here.
That's
if
good.
you have more questions, Thomas, I am sure available right
Yeah.
now afterwards.
I'm
Thank
here.
you so much for Tom. Please, can you give him a big applause? Tom, we have a gift for you. Mr. Mehmet Şenol from Thank you so much. Hold on. Özlem is coming for photo. Thank you so much. Thank you for this very, very interesting subject. I hope in the future we'll see more.
Oh, yes.
Thank you.